Good morning, and welcome. This is the Sunlit Atelier, a quiet studio on a hillside, where we're going to learn machine learning together, one gentle step at a time. That little paper crane is Kiko. Kiko doesn't speak, but Kiko notices everything. Keep an eye on him. Before we can teach a machine anything, we need a language to speak with it. So today, we begin with Python. Take a breath. Let's start. There are many languages we could choose. C++ is a forge, powerful, but heavy. Java is a formal workshop, precise, but full of paperwork. R is a botanist's desk, wonderful for statistics. But Python is the open pavilion, simple to read, simple to write, and nearly everyone in machine learning gathers here. That's why we choose it, not because it's flashy, but because it lets us think about the ideas, instead of the language. A variable is just a labeled jar. Watch the first line run. Age equals 25. The computer opens a little drawer in its memory, ties on a tag that says age and places the value 25 inside. The second line, salary equals 75,000. A new jar, a new tag, a new value. And the third, name equals Alice. Words go into jars too. Whenever we ask for age, the computer simply walks to the shelf, finds the jar with that tag, and hands us what's inside. That's all a variable is. A name, tied to a value. Rest with that for a moment. Let's walk through this code together, slowly. First, we write age equals 25, and Python quietly creates a variable named age, holding the number 25. Next, salary equals 75,000. A second variable, salary, now holds 75,000. Then name equals Alice, written in quotes, so the variable name holds the text Alice. Finally come three print lines. We print age, and the screen shows 25. We print salary, and out comes 75,000. And when we print name, Alice appears. Three names, three values, each resting safely in the computer's memory, waiting for us. Different kinds of values take different shapes. A whole number is a marble. A decimal is a droplet. Text is a ribbon of paper. A boolean is a garden gate with only two doors. True or false. A list is a tray with slots, keeping things in order. A dictionary is a card catalog. Every drawer has a name, and inside is its value. And a set is a bowl where duplicates quietly become one. Watch the two twos merge. Only one remains. You don't need to memorize these. We'll meet each one again when we need it. Let's read these lines one at a time, gently. First, count equals 10, a whole number, so Python calls it an int. Then height equals 5.9, a decimal, which becomes a float. City equals Delhi, written in quotes, that's a string, just text. Is ready equals true, a boolean, which can only be true or false. Next, scores holds a list of three numbers, 85, 90, and 76, kept in order. Student is a dictionary, the key name points to Alice, and the key age points to 25. And finally, IDS is a set holding 1, 2, 2, and 3, but the duplicate 2 quietly merges away, leaving just 1, 2, and 3. Here is a tray of 5 test scores, 85, 90, 76, 95, 88. Notice the little tags under each slot. Python counts from 0. The first marble sits at tag 0, not tag 1. So when we ask for scores, 2, Kiko counts 0, 1, 2, and brings back 76. If this feels odd, that's alright. Every programmer stumbled here once, and soon it becomes second nature. And append simply grows the tray by one slot, and places 92 at the end. Take a breath, and follow along. First, we create a list called scores, holding 5 numbers, 85, 90, 76, 95, and 88. Then we print scores at position 0, and because Python counts from 0, that first slot gives us 85. Next we print scores at position 2, counting 0, 1, 2, and out comes 76. Then we call append on scores, passing 92, and the list gently grows by one slot at the end. When we print scores again, all 6 numbers appear, and calling len on scores tells us its new length, 6. Now, let's watch the computer actually work. Slowly, number by number, we start with an empty jar called total. Its tag says 0. Iteration 1. The loop picks up the first marble, 85. The tag called score now reads 85. We add it to the jar, 0 plus 85. The jar's tag flips to 85. Iteration 2. The next marble. 90 score becomes 90. 85 plus 90. The jar now says 175. Iteration 3. 76 175 plus 76 gives 251. Do you see the rhythm? Pick up, add, move on. The last two marbles flow in the same way. 346, then 434, and the average, 434 divided by 5, is 86.8. This tiny rhythm, pick up, compute, move on, is the heartbeat of everything we'll build in this course. Every model you'll ever train is loops like this one repeated with patience. Let's trace this loop, slowly, together. First, scores holds our 5 numbers, then total starts at 0, an empty jar. The for line says, for each score in scores, do what follows. On the first pass, score is 85, total becomes 0 plus 85, which is 85, and print shows both values. On the next pass, score is 90, and total grows to 175, then 76 brings it to 251, 95 to 346, and 88 to 434. When the loop finishes, we compute average as total divided by len of scores. That's 434 divided by 5, and the final print shows average, 86.8. A list does its work one marble at a time, like a single gardener walking the rows. NumPy plants the same numbers into a perfectly ordered seed bed, called an array. And now watch error 2, one tip of the watering can, and every value doubles at the same instant: 170, 180, 152, 190, 176. This is called vectorization. When our datasets hold millions of numbers, this is the difference between an afternoon and a heartbeat. First, we import NumPy and give it the short name NP. Our scores list holds the same 5 numbers as before. In the list way, we start with an empty list called doubled list, and a loop visits each value s in scores, appending s times 2, one at a time. Now the NumPy way, we call np.array on scores, and store the result in a variable called err. Then one gentle line doubled equals error times 2, doubles every value at the same instant. Printing doubled shows 170, 180, 152, 190, and 176, and calling mean on error gives us the average, 86.8. When data has rows and columns, we reach for Pandas. Reacts unrolls the whole file like a linen ledger, names, ages, salaries, departments, everything in its place. Head politely asks the first 5 rows to step forward, so we can meet the data before working with it. Describe writes a quiet summary, the average, the smallest, the largest, and do you see that faded cell, the one the light passes through? That's a missing value. Kiko noticed it too. We'll learn to care for those in just a moment. First, we import Pandas and call it PD for short. Then pd.readCSV opens the file students.csv and stores the whole table in a variable called df, our data frame. Now we look around, gently. Printing df.head shows the first 5 rows, just enough to meet the data. Printing df.shape tells us how many rows and columns we have. Then df.describe writes a quiet summary, the count, the mean, the smallest, the largest, and finally, df.isnl.sum counts the faded cells, the missing values, in every column, so nothing stays hidden from us. Numbers tell the truth, but pictures let us feel it. A bar chart grows like potted plants of different heights, taller pot, higher mark. A line chart follows Kiko's flight across the page. Watch how the line rises as study hours rise. A scatter plot is dandelion seed settling exactly where their 2 numbers agree. One glance at these pictures, and the story of the data begins to show itself. We begin by importing matplotlib.pyplot and calling it plt. Then 2 small list subjects holds math, science, English, and art, and marks holds 86, 91, 78, and 88. Calling plt.bar with subjects and marks grows a soft green bar for each subject. Plt.title names the chart marks by subject, and plt.show lets us see it. Next, hours holds 1 through 5, and scores rises from 55 up to 88. Plt.plot draws a gentle blue line through those points. Plt.scatter rests a rosy dot at each pair. We label the axes hours studied and score, and show the picture. Now, Let's do one small, complete piece of real work. 5 quiet steps. Step 1. Load. 6 students, their study hours, attendance, and scores, all on one ledger. Step 2. Clean. Device score is missing. A faded cell. We mend it gently with the class average. 75.6. The ledger is whole again. Step 3. Summarize. Describe. Tells us the class average is about 75, lowest 58, highest 92. Step 4. Correlate. Hours studied and score move together almost perfectly. 0.98. When one rises, so does the other. Step 5. Visualize. There it is on the chart. A clear rising path. More hours. Higher scores. Load. Clean. Summarize. Correlate. Visualize. You'll do these 5 steps in every single episode of this course. Today, you did them for the first time. 5 quiet steps. Let's walk them. First, we import Pandas as PD and Matplotlib.pyplat as PLT. We build a dictionary called data, holding name, hours studied, attendance, and score, and notice device score is none, missing. Passing data to PD.DataFrame gives us df. Step 2. Cleaning. df.isnl.sum finds one missing score, and Filna gently replaces it with the mean of the score column. 75.6. Step 3. df.describe summarizes everything. Step 4. We call core between hours studied and score, almost 0.98. And step 5. plt.scatter draws hours against scores. We add labels and a title, and plt.show reveals the rising path. And that's our first day in the atelier. Variables, jars with names, lists, trays that keep order, loops, a patient rhythm of pickup, add, move on, NumPy, the whole garden watered at once, Pandas, the great linen ledger, and Matplotlib, pictures that grow. Do you see that door? Beyond it is a little village of watercolor houses, and every house wears a price tag. Next time, we'll teach a machine to guess those prices by laying one simple ribbon across a chart. Rest here a moment. When you're ready, the next door is open. Well done today, truly. See you in the village.